Hello everyone, welcome back. Today in this video we will discuss the probable questions from set theory. The first question, as you can see on the screen, you have to justify and tell which of the following are sets. The first one is the collection of all boys in your class. Now when you talk about collection of boys in your class, so here easily you can identify a boy who belongs to this collection. Henceforth, this is a set. Coming to the next one, collection of all natural numbers less than 100. So here you are well aware of the natural numbers which starts from 1 and it will end at 99. So here also you can find a number easily which will belong to this collection. It is countable also. Therefore, it will be considered as a set. Coming to the third one, collection of novels written by the writer Munshi Premchand. Now Premchand is well defined. He has written novels which is well defined and one can find any book which belongs to this collection. Okay, so therefore this collection will also be considered as a set. Coming to the next one, the collection of all even integers. Now when you talk about even integer, it is again a well-defined collection and one can easily find an integer which will belong to this collection. Therefore, this is also a set. Coming to collection of questions in this chapter. Now when you talk about collection of questions, it is well defined and you can find a question which will specifically belong to this chapter. Okay, so therefore this will again be considered as a set. Collection of most dangerous animals of the world. Now coming to this question, this is not well defined collection. Why? Because in this criteria to find a dangerousness of any animal, it can differ from one animal to other. To some people, lion can be considered as a dangerous animal. To some other, elephant can be considered as most dangerous animal. So therefore it will vary from again person to person. So therefore this collection is not a set. So leaving the last one, rest all the questions, we will find that these are all a set. Now coming to the next question, you have to write the following sets in roster form. The first question is D set is named as capital D is equals to x such that x is a prime number which is a divisor of 60. Now 60, if you find out the factors of 60, first and foremost 2's are 30, then it will be 2 15's are, then it will be 5 3's are, and then it will be at last 3 1's are. So if you consider only the prime factors, it will be 2, 5, 3. So therefore 60 can be written as, see, 2 times 2 are there, so 2 into 2 into 3 into 5. Now 2, 3 and 5 are the only elements of this set because it is mentioned over here that it has to be a prime number. As you know, 3 and 5 are prime numbers. 2 is also a prime number which is the only even prime number. So in roster form, what can be the answers? You have to name the set which is already given as capital D. That is equals to, you have to write the answer within curly braces 2, 3, 5. 2 you cannot write 2 times because in a set repetitions are not allowed. Now coming to the next example, that is set of all letters in the word trigonometry. Now trigonometry, as you can see, there are 12 letters in this word, and in this word T, R and O are repeated. If you closely look, there are 2 times T, there are 2 times R, second time 2 times R are there, and also there are 2 times O. And you know that in any set you cannot write repetition. So while you are writing in roster form, first and foremost give the name as capital E, that is equals to within curly braces T R I G O N. Again O is there, you cannot write this O because already you have written O one more time, so omit that. Then M, comma, E, comma, T. T T already you have written, so you can't write T once more. Then R, already you have written R, you cannot write R once more, so Y. If you closely write the letter once, T, R, I, G, O, N, O, M, E, T, R, Y. Look, there are 2 times R, there are 2 times O, and there are 2 times T. So all these letters which are repeated 2 times has to be neglected. You have to write for only 1 time for the 2 times. So T, R, I, G, O. Up to this you will write all the letters. N also you will write. O will get omitted because already 1 time O you have got. M, E, T, again this will get omitted because already there is 1 T. R, already you have written, so omit this, then Y. So now check with the answer. Trigonmey. Trigonmey. Okay, so that's why the answer is like this. Coming to the next question, that is, the question is given in quadratic form. So what is the quadratic form? This is x square. X square plus 7x minus 8 is equals to 0. This is x square. 2 is there at the, like this. X square plus 7x minus 8 equal to 0. And middle term by now you know to solve. This is equals to x plus 8 into x minus 1 equal to 0. So x equal to minus 8 or x equal to 1. So what are the two values which will satisfy? Minus 8 comma 1. So therefore C is named as because they have given C as the name of the set, that is equals to minus 8 comma 1. And now both are real numbers and it's given x is belonging to capital R. So we will take both the values. So this was all about the second question. Now coming to the third question, you have to write the following in set builder form. The first example is given 2, 4, 8, 16, 32. Now while we have learnt the definition and examples of set builder form previously, there I have mentioned that first and foremost you have to find out what is the common connection between all the elements. So therefore, let's do the first one. Look, the first element is given 2 and 2 you can write it as 2 to the power 1, whereas 4, second is 4, you can write it as 2 square. Next is 8, 8 can be written as 2 cube. 16, 16 can be written as 2 to the power of 4, and the last one is given 32. 32 can be written as 2 to the power of 5. So if you closely look to the set, you will understand one thing. It's actually 2 to the power of 1, 2, 3, 4 and 5, which are all natural numbers. I'm talking about the powers. Powers are all natural numbers. So therefore, 2, 4, 8, 16, 32, if you want to write it in set builder form, it can be written as, it has to be written in mathematical form. So first and foremost x, such that x will be equals to 2 to the power of n, because in each and every case I have written the answer in 2 to the power of something, comma, n will be belonging to capital N, which is set of natural numbers. And you have to now define n. 1 less equals to n less equals to 5. Why 1 less equal to n less equals to 5? Because the powers has started from 1 and ended over to 5, x such that x equal to 2 to the power of n, comma n belongs to capital N, and 1 less equals to n less equals to 5. Next we will come to the second question, that is So 5, 25, 125 and 625. That is the second one. So again we have to find out a clear connection between all the members of the set. Then you can easily write the set builder form. So now look, 5 can be written as equals to 5 to the power of 1. 25 again can be written as 5 square. Now 125 can be written as 5 cube. And the last one is given 625. It can be written as equal to 5 to the power of 4. So therefore, this 5, 25, 125 and 625 in set builder form, it can be written as x such that x equal to how much? 5 to the power of n. Now what is this n? Again n in this case also belongs to capital N. Why capital N? Because the powers are all natural numbers. It's not whole numbers or any other number. So we will talk about natural numbers only. And now define n. N will be from 1 to 4. So 1 less equals to n less equals to 4. Why the equal to sign is coming over here? Less equal to, because it's taking the values 1 and 4 also. That's why this equal to sign has to be mentioned here also and here also. So this is all about set builder form. Coming to the next question, you have to state whether each of the following is finite or infinite sets. Finite means where the elements could be counted, and infinite means the exact number of elements could not be estimated properly. So the first one is given set of lines which are parallel to x-axis. Now what is x and y-axis? You know clearly. If this is the coordinate plane, this is x-axis and this is the y-axis. So the lines parallel to x-axis, this can be the line. Again, this can be the line. This can be the line. Here it can be the line. So there can be infinite set of lines which can be parallel to the x-axis. So that's why this is an example of infinite set. Coming to set of letters in English alphabets. There are all total 26 elements in English alphabet system. So therefore it's an finite set because the total number could be easily counted. Coming to the next example, the set of numbers which are multiples of 5. The multiples of 5 means it will start, it's an infinite set. Why? Because they are infinite in number. 5 ones are 5, 5 twos are 10, 5 threes are 15. So it will go in this way: 5, 10, 15, 20, 25, 30. Now you don't know the limit of this. It will move on. We don't know the limit. Henceforth, it's an infinite set. Next one, set of animals living on the earth. Now, when we talk about set of animals, that means all the number of animals which are living on the earth is finite. There are fixed number of animals. At present, all the animals could be easily counted and they are finite in number. Okay. So, therefore, when you talk about set of animals living on the earth, it's an finite set. Now coming to the next sum, that is capital U is given 1, 2, 3, 4, 5, 6. Capital A is given 2, 3. Capital B set is given 3, 4, 5. You have to find A complement, B complement, A complement intersection, B complement, A union B. Henceforth, you have to show that A union B whole complement equal to A complement intersection B complement. Now first and foremost we will calculate A complement. Now what is A complement? A complement means from the entire universal set you have to subtract the A set. So A dashed will be equals to U minus of A. What is U? 1, 2, 3, 4, 5, 6, and what is A? 2, 3. So 2, 3 you have to subtract from the U set. So what will be the elements left? 1, 4, 5, 6. Similarly, what will be B complement? That will be U minus of B. So what are the elements of B? 3, 4, 5. So subtract 3, 4, 5 from U. What are the elements left? 1, 2, 6. Next we will find out A complement intersection B complement. Now we have got A complement and B complement. Intersection means common element. So what are the common elements between A complement and B complement? That is 1 and 6. Any other elements? No. So therefore this answer will come as 1, 6. Again, next you have to find out A union B. A union B means all the elements of A and B. So this is 2, 3, this is 3, 4, 5 without repetition. So it will be 2, 3, 4 and 5. 3 is both in sets A and set B, but we will not repeat it. For 2 times 3 we will write only 1, 3. So we have got all these. The last one is you have to show that this. Now A complement intersection B complement, that already we have found out, that is 1, 6. Only you have to find out A union B whole complement. Now if A union B is 2, 3, 4, 5, what about A union B whole complement? It means that from the entire universal set, you have to subtract A union B. So what is the universal set? 1, 2, 3, 4, 5, 6. And what is A union B? That is given 2, 3, 4, 5. So 2, 3, 4, 5, if you subtract it, what are the elements left? 1, 6. So therefore, this is also 1, 6. This is also 1, 6. So are not these two same? So therefore can't we write over here that A union B whole complement is equals to A complement intersection B complement. This is proved. So separately you will find out one by one and then you will conclude with your answers. It's very easy. Only you have to check out for the respective sets and the universal set. That's it. Now the next question is given again. Capital U is the universal set given 1, 2, 3, 4, 5, 6, 7. Capital A is given 2, 4, 6. Capital B is given 3, 5. Capital C is given 1, 2, 4, 7. You have to find out two findings you have to find out. The first one, what is the first finding you have to calculate? A complement union B intersection C complement. It may look critical, but it is not. Very slowly and very minutely we have to calculate one by one. First and foremost, we will calculate the part which is there inside the bracket. Now B you know, C dashed you don't know, that is C complement. So first and foremost, let's calculate C complement. So what is C complement from the question? C complement will be again U minus of C. What is U set? 1, 2, 3, 4, 5, 6 and 7. And what is C? 1, 2, 4 and 7. So 1, 2, 4 and 7 you will strike off. What are the elements left? 3, 5, 6. These are the three elements which are left. Now you calculate. Now what is B given? B is, because inside the brackets it's given B intersection C dashed. C dashed we already have found out. Now what is B? B is given 3, 5. Now you have to calculate B intersection C dashed. That means the common elements between B and C dashed. What are the common elements between B and C dashed? Clearly it's 3, 5. Now find out the entire part. A complement. Okay, now A complement also you don't know. What is A complement? A complement is again U minus of A. U minus of A means, first and foremost, check out for the elements of A. What are the elements of A? 2, 4, 6. So strike off 2, 4 and 6. What are the elements of now A? A complement. It is 1, 3, 5 and 7. So 1, 3, 5 and 7. So therefore we have found out all the items. So A dashed or A complement union B intersection C dashed. B intersection C dashed is 3, 5 and A complement is 1, 3, 5, 7. So you have to just find out the union of these two. That is 1, 3, 5, 7 union 3, 5. So you have to write down all the elements but no repetition. So 1, 3, 5 and 7. So here comes your first answer 1, 3, 5 and 7. Separately you calculate the working of the brackets first, then find out the entire one. This is all about subpart 1. We'll come to the subpart 2. In subpart 2 you have to find out B minus A union A minus C. What is B minus A? Brackets work we have to do first. So first we will find out B minus of A. That is elements in B but not in A. That is all about B minus A. So what are the elements which are present in B and not in A? So B minus A will be equals to 3, 5. Look, 3, 5 is in B but not in A. So B minus A will be 3, 5. And what is A minus of C? A minus of C means elements in A but not in C. So 2, 4, 6 are elements of A and 1, 2, 4, 7 are elements of B. So only the element 6 is the only element of A that which is present in A but not in C. Look, 2, 4 is here also, 2, 4 is in C also. So 2, 4 we can't take, 1 we can't take because it's in C. So what is the element left out in A? That is 6. So A minus C equal to 6. So now you have to find out B minus A union A minus of C. So that will be equals to how much? So both union we have to find out. That is 3, 5, 6. So that will be your answer. So in this way, whatever findings you will be asked to calculate, easily you can find out by doing the brackets work first, then you complete the entire part. Keeping in mind what is U and what are the elements of the respective sets. Now coming to the next question, that is question number 7. You have to shade the Venn diagram which will represent C dashed intersection A union B. As you can see in the question, there are 4 options and you have to tick the correct option. So let's draw the Venn diagram first. Set A, set B and set C. As given A, B, C. Now first work of the brackets we have to do A union B. So let's mark A union B. This whole part is A union B. With C dash, that means C complement, you have to calculate the intersection part. C complement means leaving C the entire part. This is all about C. So leaving this part, you have to shade the rest of the part with opposite stroke because it's a question of intersection. So leaving C, as you can see, I am shading the rest of the part. So which is that part which is getting shaded 2 times? If you look closely, this much part is getting shaded 2 times. If I draw once again the common shaded part, this is A, this is B and this is C. So this much part has got shaded 2 times. This and this part, which is option B. So this type of questions can also come. If you have the good grip of Venn diagram drawing, then easily this type of sums will also not be a problem for you. Now coming to the next question, question number 8. This is also another set of questions where you have to draw Venn diagram for 3 sets A, B, C and you have to shade the region. I'm doing the first one as because I have cropped these questions from certain books, so therefore the numberings of that books are given. The first one I'm doing, which is given in the question, this one. A intersection B complement intersection C. A, B and C, if I'm drawing three sets, we have to find out this shaded region. So A, first and foremost, when it's a question of A, let's color A one by one. Then intersection, that means opposite shading will be done. B complement, that means leaving B we have to do in different shading. Make sure you don't color B. So look, leaving B I have colored the entire part. And what is the last one? Intersection C. So again shade C with different stroke. Now which is that particular part which has got shaded all the three times? This much part. So this much part has got shaded all the three times. Like closely if I draw once again, this is A set, B set and C set. This is the universal set. This much part has got shaded. So for the first one, that is A intersection B complement intersection C, this is the shaded part. Another subpart we will do, which is as per the question, the 57th one. A complement union B complement intersection C. For that, let's draw three sets A, B and C. This is A, this is B set and this is the C set. First, B complement, work of the brackets has to be done first. B complement. What is B complement? Leaving B whatever part is there, that is B complement. Intersection C. So C has to be colored with a different stroke. So which is that part which has got colored two times? This much part. So let's color in this way so it is prominent. So this much part we have got from the second part. Now with that, this is set C. With that we have to find out A complement union. What is A complement? Leaving A, whatever part is there, let's shade with the different similar shade, so it will be easy for us to find out the union. So leaving A, let's color the rest of the part. So which part you are getting as common? So leaving this much part, follow the line of my pen. Leaving this much part, rest the whole part will signify A complement union B dashed intersection C or B complement intersection C. So this is A, this is B and this is C. Leaving this much part, the rest of the part. Whatever you will get, that is all about the question number 57. So this is A complement union B complement intersection C. So you will all do at home this one, this one and this one. 2 I have shown. 55 and 56 one are easy. With 2 sets only you can understand and do it. 53 and 54, 57, 58 are all the same. So you can do it on your own. And then if you have any difficulty, let me know in the comment box.